Hi everyone. Today's topic is epsilon closure. Epsilon closure of any state Qi, for example, is nothing but set of states. I will write here epsilon closure of Qi is set of states including Qi. So if I want to find epsilon closure of Qi, so that includes Qi itself first. Then in addition to that, wherever Qi can reach by any number of epsilon transition. For example here, suppose Qi can reach to, this is a Qi can reach to Qj using epsilon transition, then I will add here Qj. If again there is a epsilon transition from Qj to Qk, for example, then I will add here Qk. What does it mean? Wherever Qi can reach using epsilon transition, set of all these states is nothing but epsilon closure of Qi. Let's understand with few more example. I want to find epsilon closure of Q0 in this given nfa. This is epsilon nfa is given to us, where I want to find epsilon closure of all the states. First, epsilon closure of Q0. What is it? Epsilon closure of any state is nothing but set of states. That's the first thing. That is a set of states including itself. Here Qi, so including Qi. So I want to find here epsilon closure of Q0. So first add Q0. This is applicable everywhere. Epsilon closure of Q1. So add Q1 first. Epsilon closure of Q2. So add Q2 first. So epsilon closure of any state is nothing but set of states including itself first. So here I have added Q0. Then wherever Q0 can reach using epsilon transition. Now I want to find here epsilon closure of Q0. So where Q0 can reach? Q0 can go to Q1 using epsilon transition. So add Q1 here. Then Q0 can reach to Q1. Then using the epsilon transition again, it can reach to Q2. So add Q2 also here. In short, Q0 is able to reach to Q1 using epsilon transition, able to reach to Q2 using epsilon transition. So I am adding here Q1 as well as Q2. And Q0 itself is already added. Similarly, epsilon closure of Q1 is set of states including itself. So I have added here Q1. Then wherever Q1 can reach, now see Q1 has one transition of epsilon, it can reach to Q2 using epsilon transition. So add Q2 also. Hence epsilon closure of Q1 is itself plus where Q1 can reach using epsilon transition, that state is added. Next, epsilon closure of Q2. First of all, set of states. So Q2 is also added including itself. Then any transition from Q2 with epsilon having Q2 having one transition for C, there is no epsilon transition from the Q2, so this will close here itself. So epsilon closure of Q2 is Q2 only including itself, and there are no other states for epsilon transition from the Q2. So these are the epsilon closures of Q0, Q1, Q2. Let's have one more example. In this example there are four states Q0, Q1, Q2, Q3. So first try to find epsilon closure of Q0. It is nothing but set of states including Q0. So add Q0 here. Then Q0 is added. So to which state Q0 can reach using epsilon transition? So Q0 is reading epsilon, can reach to Q1. So add Q1. Then from Q1 there is again epsilon transition. It can go to Q2. So add Q2. From Q2 any other epsilon transition? Yes, it is there. It's going to Q0 itself. So Q0 is already present here. So epsilon closure of Q0 is Q0, comma, wherever it can reach to Q1 using epsilon transition. It can reach to Q2 using epsilon transition. So Q0, Q1, Q2 is added here. Similarly, epsilon closure of Q1 is a set of states including itself. So Q1 is added. Here also epsilon closure of Q2, set of states including itself. So Q2 is added. Epsilon closure of Q3, set of states including itself, so Q3 is added. So first add that specific state. Then in this case, for example, epsilon closure of Q1 is set of states including itself. So Q1 can reach to where? Q1 can reach to Q2 first using epsilon transition. Q1 is reaching to Q2 using epsilon transition. So Q2 is added. From Q2, is there any epsilon transition? Here is a 0. Here is the epsilon transition. It's going to where? It's going to Q0. So add Q0 also. See, epsilon closure of Q1 is Q1 itself, then reaching to Q1, Q2 using epsilon transition, Q2 having epsilon transition for Q0. So it's also added. Next, epsilon closure of Q2, set of states including itself. So Q2 is added. Go to Q2. Find out if any epsilon transition. Here is a 0 transition, here is a epsilon transition. So Q2 having epsilon transition, it's going to where? Q0. So add Q0 here. From Q0 there is a epsilon transition, going to where? Q1. So add Q1 here. Q1 having epsilon transition going to Q2. Q2 is here. No need to add it again. So epsilon closure of Q2 is Q2. Then having epsilon transition Q0, having epsilon transition Q1. So Q2, Q0 and then Q1. Next one is epsilon closure of Q3. Set of states including itself. Q3 is added. Is there any epsilon transition from Q3? No, there is a transition for 1. So epsilon closure of Q3 is Q3 itself. In this way we can find out the epsilon closure of any state. This will be useful when we will convert epsilon nfa to dfa. The first step will be finding out the epsilon closure. Thank you for watching.